All right, I guess we'll turn the reins over to Bob, K0NR, and looking forward to this.
Try a little unmute. Yeah. Okay. Let's see. I need to share. Okay. Got the first slide up. Can you guys see it?
Yes. Mm-hmm.
Okay. I'm going to try something a little bit different tonight. Going to have an antenna. We're going to talk about antennas. We're going to do it as a panel discussion. And I've seen this used in various conferences, and what we'll do is we'll have I've had Steve, Chip, and Al agree to participate. I appreciate that, and the four of us will do kind of a brief presentation on something of interest to us related to antennas, and we'll hold it to no more than 10 minutes. I'm gonna clock these guys because I know they like to talk about antennas. Myself included, and so we'll try and, if we stay under 10 minutes each, we'll be 40 minutes into it, and we'll have plenty of time left for Q&A. And so I'd ask you to hold your questions till then, and be thinking about antennas in general. This is a good chance to toss a question out, have the panel give different perspectives on it, and then maybe some of our club members can chime in as well. We've got a wealth of knowledge out there. We actually started some interesting antenna discussions in the Connect time before the meeting actually started. It was on antennas. A lot of it was on antennas. So that's what we're going to do. I'll kick it off with just sort of reminding you of some common antennas. And of course, the dipole is kind of the standard, right? Half-wave dipole. It has that in 3 dimensions. It has that radiation pattern that looks like a donut. That's if the dipole's out in free space, right? If it's laying close to the ground, it's going to reshape this thing. And if you look down the end, you're just going to see radiation like that. If you look from the top, it looks like this. And a dipole, being a half-wave long, is just 2 quarter-wave sections. So I can construct one like with a quarter wavelength of wire and another quarter wavelength of wire wired up to ground and center conductor. So that makes for a simple dipole. This is kind of a zoomed-in view of how you might hook up the outside braid or shield and the inner conductor. Pretty basic stuff. This one thing I think maybe people don't appreciate quite as well, so I want to make sure I emphasize this. When there's something magic about the length of a half wave, I like to think of it as if I was an electron minding my own business, sitting on this dipole someplace, and somebody hooks up a radio signal that is exactly a half wavelength, consistent with that dipole. I'm going to find myself being pushed from one end of the dipole to the other, and it turns out a half wavelength is just the right length to make that happen really, really well. And we have this phenomena of resonance. It really likes to resonate and create a electromagnetic wave off of that antenna. Let's see, that may not be it's super accurate description from a physics point of view, but it's close enough for our purposes. And so then what happens is you get, the way this is set up, we have like AC cycle A and AC cycle B. So on one polarity, when the voltage is positive over here, one side of our, the high part of our sine wave that we're driving this with, I get some voltage, and the voltage decreases as we go towards the center of the dipole, and then it increases in the opposite direction towards the other end. And then on the opposite cycle, when we go through our sine wave and we change to the other half of the cycle, of course, this one is going to end up being negative, and the one on the right becomes positive. So now you can use your imagination, because we don't have this animated or we don't have video. You can imagine this thing sort of flopping back and forth between the cycle A and the cycle B's, going back and forth. But the key takeaway is, notice that the voltage maximums are always at the end of the dipole. That's where the voltage is big. And then as you go towards the center, the voltage goes through zero, gets very small, and then the polarity changes, but basically the voltage is also big, is large at the other end. And I've also got the current that dashed in here. Notice that the current is zero at the ends of the dipole and hits maximum in the center, and then it's zero again on the other end. And I go, well, does that really make sense? And I go, yeah, that makes perfect sense. You think about it. Let's start with current. There's no place for the current to go when it gets to the end, right? Again, may not be 100% true, but in our ideal dipole, once it gets to the end of the wire, there's no place to go. So you'd expect zero current at each end, and then you expect it to be maximum in the center. And voltage is kind of similar. You'd expect the voltages to peak up at the end of the wires as the potential reaches maximum. It tends to stay low in the center. You go, okay, Bob, that's great. Why do you think that's important? And it's important when we start looking at impedance. And so you may recall impedance is just the ratio of the voltage to the current. And we're dealing with RF signals, so we're going to think about it as an AC situation, not DC. It's an AC voltage and current. So that ratio is going to be the impedance. And we have an impedance all the way up and down this antenna. Every point has its impedance, and we normally connect in the center, and that's actually the lowest impedance point, is right in the center. And that impedance is about 70 or 72 ohms. I just looked it up this morning in the antenna book. Oh, quick commercial interruption. If you really want to get into antennas, buy the ARRL antenna book. I just pulled it out again and looked at it. It's like there's so much information in there. But anyway, they were showing that the center feed point impedance will vary depending on how high off the ground your dipole is. But in free space, it ends up being about 70 ohms. Yeah, charges accumulate at the endpoints. That's where the highest voltages are, and current flows. Already said that. So we said 72 ohms in the center, but what happens if we move to the ends? The voltage gets a lot larger, and we said the current is going to get really small, and so voltage over current is going to get bigger. The impedance is going to be very high on the ends of these things. How high? I'd say thousands of ohms. So maybe 2 kiloohms or 3 kiloohms or something like that. And Steve's going to talk about how you can actually go ahead and feed that antenna from the end, which is kind of an interesting thing. But just be aware that the impedance of this thing is changing depending on where you're at on the dipole and where you choose to hook up. Okay, that's the dipole. We can take that and turn it on its end. And if we were talking about ground planes during connect time. If we have a ground plane underneath it and a quarter wave radiator, I guess correct term for that is a monopole, because it only has one thing radiating. That ground plane creates an image that is another, through reflection, that is another quarter wavelength. So it actually behaves a lot like a dipole. It's a half wavelength, kind of vertically oriented. So it's a common antenna, and it really is a sort of a close cousin to the dipole antenna. And then the last one I wanted to mention was just the Yagi. And here the idea is we want to get some gain out of this, right, and get some directivity. We have our driven element, which is a half wave dipole, and then we put a reflector behind us, which is a little bit longer. It's going to be spaced about a half wavelength. And that reflects the signal to the left as we look here. And then we have directors, which are a little bit shorter, and those sort of attract the signal and also direct it towards the left. And that's how we get gain out of a Yagi antenna. Okay, I think that's everything I was going to cover. I'd ask you to hold questions till the end, and we can kind of loop back around and definitely jot down your questions so we have some good discussion points. Now I will hand it over to Steve to talk a bit about end-fed antennas.
Okay. Can you see my pointer or the cursor?
No, they can see my pointer because I'm sharing.
Okay. All right. Well,
I'll try and follow you.
I won't point. Anyway, dipoles versus end-feds. As Bob described, the dipole is your Class A, easy to build, simple antenna. It's very underrated. It's actually a very good antenna and the basis for a lot of gain antennas. And it's simple to construct. The feed point typically is 72 ohms, somewhere near 50 ohms to match to coax, which is good. Makes it pretty simple. If you've got some coax, you can cut a couple pieces of wire, quarter wave length long, and put up an insulator and feed it and hang it up in the trees. And whether it's an inverted V, which would mean the elements droop down from the center on both sides. But you got to remember that the high current point is the center. So that's where your signal is going to radiate from, or at least all the current, all the power, so to speak. But something changes if you want to make a half wave antenna, and that the impedance becomes very high, or somewhere around 4,500 ohms. And to feed that, there's ways you can do that. The half wave end-fed antenna is really a nice antenna from a portable standpoint. And also, if you've got covenant restrictions, or you want to put up an antenna and not have the center of it with a piece of coax drooping down from it and have to support the center of it, it's a great antenna from that standpoint. And from my standpoint of portable, end-fed half waves are the way to go. Next slide, please. So, doing some research on the internet, there's a bunch of websites that talk about creating a transformer to transform this 5,000 ohms, so to speak, down to 50 ohms. And you can build, there's all kinds of plans on the internet how to make a 49-to-1 transformer. It can be built on very small toroid for low power and increase the size, obviously, for high power. Or there's off-the-shelf commercial. They're called, well, yeah, they're basically a transformer as opposed to a balun, because the nature of it. But there's off-the-shelf ones that are very good from the standpoint, and actually multi-band from the standpoint that they work on harmonic-related bands, depending upon the length of the half wave that you put up. QRP Kits has one here in the lower right-hand corner that I think is under $20. But it's by nature of their name, QRP kits, it's rated for probably about 10 watts. My antenna, which is the next one up, can HRO and I think DX Engineering and several other vendors market these, and typically they're rated at 200 watts and on up. But so you don't have to make this thing up from scrap parts. You can buy it off the shelf if you want to. Another antenna, not to be confused with the end-fed half-wave antenna, next slide please, is the end-fed random wire antenna. And the term random wire is really a misnomer. All these links that are listed in red just underneath the title up there, they all are non-resonant. That is, they're, as Bob was describing earlier, as you move down that piece of wire, that halfway, the impedance changes. And the result is that if you use a 9-to-1 balun, and an antenna tuner, which a lot of the newer radios nowadays have, you can make this antenna play on a lot of different bands, dependent upon the length of wire that you put up. And I've tried this with these various lengths of wire on various summits, because some summits there's not much real estate, and I'm lucky to be able to put up a 29-foot piece of wire, and sometimes just draping it over the side of the cliff, or draping it over, several bushes or dead trees, or in some cases my trekking pole, and launch a signal using the KX2 built-in antenna tuner and a 9-to-1 balun that I built. So, long story short, you can build it yourself. There's plenty of plans out there to come up with a 9-to-1 balun, and string up a wire outside. I would highly recommend that you use any one of these lengths of wire at the top of the slide. And then lead that wire back into the balun, and from the balun to your radio room via coax, and give it a try. There's also a lot of off-the-shelf 9-to-1 baluns that you can find at your local candy store, so to speak. So, yeah, I think that was it. The main point is that there's basically 3 different end-fed wire antenna setups. One is the half wave. One is this end-fed random wire, which was really not random. That's a misnomer. It's a very specific length. And the third is a random wire, really, which you just string up some wire and use an L network to feed your antenna. So that's my story. I like to think of my antenna as a light that I'm trying to get the most power in, and make it shine as best as I can, considering I'm typically using very low power. So,
okay,
Chip, I think is up next.
Yeah, thanks, Steve. That was great. Let's move on to Chip.
Bob, not if you can hear me. Okay.
Yeah, you're on.
This is one of my 2 traveling systems. I also have a travel trailer, but haven't worked as much radio in that. And my camper here with the horse trailer, I spent a lot of time in this thing. And when I was looking for a new camper to pick up, I specifically went to the Lance models that have an 1/8-inch solid aluminum roof, which gives me an immediate advantage in doing anything antenna related. while I'm moving and occasionally stopping for lunch or something, or for an afternoon and want to be able to use an antenna, I have actually 3 antennas semi-permanently mounted on top of the camper. 2 of them are PL259 feed-throughs that I generally have VHF, UHF antennas on. Third one is one of the bayonet quick mounts. So I'll show you a picture of that in a few minutes. And on that quick mount, I have a short whip on a spring load. So if I hit a tree with it, it doesn't destroy things. And that's surprisingly usable. I'll show you a picture of that in a minute. Once I get to a campsite, I'm even if I'm there for an extended camp, I'm generally looking for a quick antenna setup. I don't really want to spend too much time messing with it. And the most effective ones I've found are a number of different long wire types that you throw a weight over a tree with a string and pull them up and tie them off to the camper, and they can be very effective. I've also got a base-tuned long whip that I'll show you in a minute, and a shorty base whip that's kind of interesting. The primary, Bob, if you can look at the radio rack right in the middle there, the picture, there you go. That's the one that I've actually got semi-permanently mounted inside the camper. That's IC7000, which I still think is one of the finest radios ever made. It's an all-band, all-mode. And I'll talk more, I'm going to talk a little bit about tuners at the end of this, because I think it's unfair to talk about any kind of traveling antennas without talking about tuners a little bit. So I told Bob I would hit on that. That MFJ 929, I've got a couple of them, and I love it. I'll tell you why in a few minutes. These are all radios that I currently have, which is a little bit embarrassing at this point. Generally, I use the 7300 at home. I have taken it traveling a few times. I've become very fond of this little Ziego G90. It goes up to 30. That's the second one from the left. That goes up to 30 watts barefoot. It's very tiny and portable. It's all HF bands, has a great spectrum analyzer capability. It's just a cute little radio. The fourth one is the ever popular 857D, which I still use a lot. It feels more like a ham radio than any other radio I've used on HF. There's just something about it. I'm going to be talking mostly about HF, but just, Bob, if you go up to that, above that is the 8500. Sometime when, over to the right, there you go. Sometime when we can get together again, I will bring that thing in, because somebody let an engineer loose with the microphone. The microphone has, I think the last time I counted, 48 controls on it, which is just mind-boggling. It's a beautiful thing to see. Then the 991 I actually carry around with me quite a bit, and it's my tabletop radio when I'm camping. So go ahead and hit the next slide. Normally on the camper, as I said, for semi-permanently attached, that upper picture is it's a 5-foot whip with a spring load and a quick connect, so I can push that down if I can climb up the ladder, twist it, yank it off, and put a different kind of antenna on that. It makes it real easy to interchange. And then I've got 2 of these, the lower picture there, 2 of the PL259 through that aluminum roof. Usually I've got UHF, VHF antennas on those, but I've got one PL259 type HF antenna that I put on one of those occasionally, and I'll show you why. And as I said, the radio rack down the lower left is sort of permanently mounted as my console inside the camper, and if I stop for lunch somewhere, or dinner, I can turn that on and do a quick scan of the bands and see if anything's working. And it's for as untuned and short and inelegant as that little whip is, I've made a surprising number of contacts with it.
This guy up here?
Yep.
What'd you say the length was?
It's about 5 feet, stainless steel, on a spring. Yeah.
And so that's a vertical, and what's the ground associated?
The ground is the whole roof of I actually have some wire going from that mount down to a roof connection. You can't see it there.
Okay.
So I've got the whole roof for a ground plane.
Okay, good.
Hit next slide. Okay, so up at the top is that PL259 based 5-foot variable base coil that I talked about. You can unplug that banana plug, plug it into other things there. Probably you've seen those on eBay. You can generally pick them up for, I think, around 60 or 80 bucks. For something that you want to get up quickly and in less than 8 feet, I've made contacts on it. It's a reasonable antenna. It'll handle 100 watts. It's easy to use. You have to be able to get to it to change the band you're working, but it's actually pretty darned effective. The second one there is a 17-foot whip, or a telescoping whip that I got from MFJ. And at 17 feet on that aluminum roof with a tuner, I've done a lot of work with that. It's a quick thing to put up. It works well, and it's I think that's like a $25 antenna. Gives me 17 feet in the air. It's already up 12 feet on top of the camper. It's surprisingly effective for something to get going real quickly. The next picture there is a couple of long wires. That one on the right is something I haven't been able to find again. I call it a end-connected dipole. If you look at it, you can see there on the left part of the coil, it looks like it's zip cord. It has about 25 feet of coax. Well, actually, it has about 70 feet of coax. And then another wire run back along the coax and wrapped to it for about 50 feet. And then 40 or 50 feet of just long wire off the end of it that I throw up into a tree. So you wouldn't think that having that wire just back along the shield of the coax would be a very effective radiator. But from everything I've used with it, it acts like a dipole.
Yeah.
With an end connection, so it's kind of convenient. So again, I haven't been able to find those again. If I find one, I will buy one. I think I paid $60 for that on eBay. It stretches out to about, the actual antenna part of it's probably about 100 feet, and then 20 feet of coax coming down from it. It's kind of an interesting antenna. Easy to put up because I just tie a wrench onto a string, throw it over a tree, pull it up, and I'm on the air. And as I said, it's pretty effective. The one on the left there is just a standard long wire with a balun or a transformer, as Steve pointed out, and it works great. I've used it in a lot of bands, made a lot of contacts with it. And then finally down at the bottom, this is actually a 27-foot telescoping mast mount antenna with a variable base coil. If you can see, it's kind of hard to see in this picture, but down at the bottom there, there's a coil, an air wound coil of wire right above there. Just up, and then there's a wire clip that you put onto that to tune it to different bands. And that's actually, it's a little bit more work because I have to figure out something to use for a mast to tie it to. And I have carried around I've got one of the military 5-foot section aluminum mast sets that I can run up to whatever height I want. And I've used that with that a few times, and it's to get a nice tunable vertical mast that's a reasonable length. It does a pretty good job. Okay, let's go on to the next one. I'm going to talk a little bit about tuners.
Yeah, one minute to go.
Okay, I'll get through real quick. Tuners, for quick setup antennas, you're generally going to want to use a tuner. They're also can be known as dummy loads. They add inductance and capacitance just to match impedance so your transmitter feels good about producing full power. They do not make your antenna radiate any better. Still almost always use one. Most modern radios, a lot of modern radios have a built-in tuner, but they're usually limited to about 3-to-1. Externals can go up a lot higher. They come in automatic versus manual, idiot light versus full instrumentation. I've got one of the LDGs over on the far right. Having just a green light annoys me to the point of distraction. So I've gone to all the MFJs have incredible, those are the ones on the left there, have amazing instrumentation. And I literally have tuned an electric fence with them. And I'm very fond of the 929 on the far left. They're the same size as a lot of smaller all-band, all-mode radios, so they stack nicely. Nice little tuners, recommend highly. The one on the right there is exactly the same width as my 7300 and 991, so they make a nice stack with that, and it has the cross-point meters as well as the LCD display. And that's all. We can do a whole meeting on tuners sometimes. Matter of fact, I think we have.
Okay, very good, Chip. How much is that MFJ tuner?
That one's about $230. And if somebody wants to get a tuner, that's the one I recommend. It's a wonderful little device.
Okay. All right. Nice job. Thanks. Let's go on to Al. He's going to talk about a copper antenna.
Yeah, I had about 7 years ago, we had a tech day, and Bob made a discussion on antennas, and he was talking about fan dipole antennas. Fan dipole antenna is one that spreads out like a regular dipole, except at the center, you'll end up with two sets of wires that connect to the insulator in the middle. One for one band and one for the other band. And when the signal comes out, it runs to whichever wire it's resonant for. So I went home and I thought, well, what the heck? I wonder if I can, and I've been making antennas out of copper for a long time. And I thought, I'm going to try a fan dipole for a dual band 2 meter 440. So I started one Saturday afternoon, started building this thing. And when I first started out, I built it as if it were regular dimensions for a 2 meter and a 440. So the 2 meter sections on each side of this dipole were 57 inches long, and the 440 sections, those smaller sections, were only 19 inches long. And I checked the SWR, and it told me, doggone, man, you have these things too doggone long. So I just started trimming, and I would go alternately in an iterative process back and forth between the two bands, trimming an inch off at each cutting. So I ended up with an antenna that looks like what you have there in image A. The overall antenna is only about 2.5 feet long from end to end. And if you take a look at the SWR graphs there on the bottom, which Bob ran through an analyzer that he has, across the entire band for both bands, you have the SWR that's less than 1.4, I think, to 1 on the 2 meter side and 1.6 to 1 on the 440 side. I had just done this with a simple SWR meter, and when I went out in the driveway just to test it out, I live in Monument, and I sent out a CQ on 2 meters, and I picked up some guys who were down at Turkey Creek at Fort Carson, which is like, I've calculated out about 40-some miles away to where they were, and that was only on 5 watts. So the antenna really worked well. Let's go to slide number 2. This is what the pieces look like when you're putting it together. That upper picture on the left-hand side is just a 1/2-inch copper pipe, and you buy those pieces, and even though I give the dimensions on this drawing, and if you go to my webpage, WBØTGE.com, I have a link to a PDF for constructing this antenna. And honestly, I've had people from all over the world contact me that have built this antenna and have really had great success with it. When you're putting together copper antennas, the important thing when you're soldering is to make sure that you clean it using a wire brush or steel wool or something like that. And you use flux in this antenna. And I know in electronics, you want to make sure that you use the right kind of flux, like with rosin, core, and all that stuff. But this isn't like regular electronics. This is like plumbing. So you just use regular, non-lead solder or lead solder to assemble these things. If you're gonna build an antenna like this, you want to cut the pieces to the lengths that are kind of given, and then do an SWR check on it before you solder it together. You want to get it as close as possible, the lowest SWR that you can when you're building the antenna. And let's say that as you're trimming an antenna back and forth, now you can take this antenna and you can build a 2-meter J-pole antenna. It would be a section that looks just like that upper left-hand corner, but with given dimensions, and you can find these dimensions out on the internet. If you ever are trimming an antenna length down to what you're trying to get to, and you end up cutting it too short, well, no big problem. You just whack off a chunk of copper pipe, put a coupler in, put an extended piece out, and you're looking good. So these kind of antennas made out of copper pipe, you can make just about any kind of antenna that you want. Dipoles, verticals, almost any frequency can be made out of this kind of material, these copper dipole. Now this kind of antenna can also be made with aluminum. Let's say you can get some aluminum rod. You can make antennas like arrow antennas that they are on the internet. You can buy from Arrow up in Wyoming. But what you can do is you can go out and you can take a look at you can get dimensions for their antenna and you can build it yourself. All you need is a small piece of angle iron for the base and a section of aluminum rod for the vertical, let's say on a 2-meter antenna, and for a short stub, you use the same material and you just attach it to the angle iron. Soldering is an easy thing to do. Once you clean the parts and you put them together, fitted them together with flux on it, then what you want to do is you want to get a propane torch and you want to bring it down and start heating the copper pipe. And while you're heating it, you take your solder and you start touching it to the copper. And there will become a point where the copper tube has gotten hot enough that it will be able to melt the solder. You don't want to put the solder into the flame. You want to heat the copper pipe with the flame of the torch, but you want it a little away from where you're actually going to be putting the solder into the joint. So once the copper pipe gets hot enough and you are touching the solder to that joint, as soon as it gets hot enough, the solder will melt and it'll just get sucked into the joint. And it distributes itself all the way around the joint. You don't have to worry typically about putting solder all around. It'll suck it in and it'll put it around the joint. And then afterwards, when you take the torch away and you have the solder away, the solder piece that you have in your hand away, you can take a damp cloth and you can wipe around that joint and make it a nice clean joint. Soldering is just a skill you can learn in about 3 minutes, just playing around. It's not a very hard thing to do. One of the things that Bob was thinking about, and I've heard from other people too, that makes this antenna so nice is that it's very broad-banded, like you saw on those graphs. And the reason is because it's a very thick element. It's a half-inch thick element. And that seems to expands the band characteristics to make it very broad. If you only had a piece of wire then you'd end up with a section only maybe several megahertz either side of wherever you happen to be tuned to, capable of making contacts with a low SWR. But the characteristics of this are very broad, and I just knocked my socks off when I built this thing. You look at the dimensions. Is my image?
1 minute.
Yeah, can people see me?
Depends how they have their screen set up.
Yes, I can see both you and the screen.
You can see me?
Yeah.
Yeah.
Okay.
Yeah, we see you.
Okay, I'm just gonna. This is how big that antenna is, and it's. I mean, you can use it mobile or attach it to anything. You can attach it to a tower if you want. And what I have here is this is a plastic of CPVC coupler that you can buy at the Lowe's. I think Home Depot used to carry it, but they don't carry it anymore. But Lowe's does. And I just have a wood dowel that's attached to it. And then down here, this is to keep currents from running back down on the cable. But it's very light. You can use it vertical, horizontal, or whatever. And it's a great little antenna for carrying around and using. So that's it for me.
All right, right on time. I was glad you mentioned the polarization thing. That one can be used either way. Oh, I was going to make one comment. I think on that antenna, are you guys hearing me okay?
Yep.
Yeah.
Okay.
Yeah, you're fine.
I think, I always think of, so some of these antennas are really finicky or fiddly, like the one Chip had with the coil at the bottom, and you gotta take your little clip to get on the right turn of the coil. You have to kind of fiddle around with it and to get it to resonate or get it to work on the frequency you care about. I think Al, this one is actually not very fiddly. Like if you cut it to the dimensions, it's just going to work, right?
Mm-hmm. Yeah. I've only had one guy that had a problem, and he ended up just not being able to cut it correctly originally, but he got it cut. And like I said, once you're putting it together, if you don't end up with the SWRs that you're looking for, just adjust it. Before you put the end caps on the copper pipes, just keep fiddling with the length, and eventually both bands will come down to low SWR.
Okay, thanks. Well, now we'll move to Q&A panel session. What questions do you have about what you've heard? Either, Steve had the end-fed antennas, and Chip talked about the camper stuff, and the tuners is another hot topic, or just questions in general, any kind of antenna questions you might have.
Hey, Bob, this is Robert. Quick question on grounding while portable. It seems like it's a little bit of a lots of different opinions on it. What are your thoughts on if you're doing SOTA or just field work about grounding your equipment?
Yeah. That's actually a pretty rich topic, pretty relevant. I saw there was a crazy discussion on the POTA the Parks on the Air Facebook page. Some guy was trying to figure out how to ground it, and everybody was going, "Why are you grounding your antenna for a temporary installation?" I think the trouble with talking about grounds is there's multiple reasons for a ground, right? One is safety ground, green wire, keep the 60 hertz from 60 hertz AC line from hurting you. Some antennas perform better or basically require a ground or a ground plane of some sort. And then there's just the general issue of RF grounding for lightning protection and stuff like that. I'd argue that when you're portable, those things don't matter except for antenna performance. If there was something about your antenna that needs to be grounded, you probably should do that. But Chip, any thoughts on that? And then we'll go to Steve. You're muted, Chip.
There we go. Can you hear me now?
Yep, got it.
Okay. Yeah, usually when I'm camping with the horse trailer, I've got a big ground for my electric fence anyway that I run to a couple of places. Otherwise, the horses have an unpleasant tendency to walk through the electric fence at midnight. So I usually connect to that ground and use that when I'm not running the electric fence, because that 1200 volt zap on the electric fence doesn't work well with antennas. But just to check that, there have been a couple of times when I was out without the horses, operating tabletop outside the camper, and I hadn't bothered to set up a formal ground. And I thought, what if I do stick a 12-inch nail tent stake in the ground here and run a wire to it? Is that going to make any difference? To my surprise, I found that it actually did make quite a bit of difference, both in my receive capability and the reports I got from my outgoing signal. So if you're going to be somewhere for a little while, it's probably worth sticking a conductor in the ground and running a wire to it.
What kind of antenna were you using?
In that case, I was using that weird end-connected dipole thing. so
Yeah.
Who knows what kind of RF characteristics we're going with it.
Okay. Steve, what kind of ground rod do you carry on your SOTA activations? I'm thinking maybe 8 foot long, and you take a big sledgehammer along.
Right, at least a 10-pound sledge to get that sucker in the ground. I've been on a couple of summits where they had one summit had a cross at one time that was erected, and they had all kinds of soft steel. I don't know if it was steel or copper, but they had a lot of wire that was used to guide this thing up, and it had all fallen down. There was just this mess of wire that kind of ran all over the place, and I connected into it. It really changed when I tuned up the antenna. I was using a long wire that was draped over a tree, and the matching of it was a lot different than what it normally was. But I got the SWR down to what made the transmitter happy, and I couldn't really tell if it improved. I still had a lot of people calling me and giving me signal reports. So if that situation arises again, I'd probably take advantage of it. But usually if I'm worried about the big dark cloud that's heading my way, it's time to pack up before my hair starts standing up and, touching stuff and getting zapped. It's time to be down the mountain.
Yeah, the lightning safety kind of issue.
The other issue that one of the, I forget her name, I think she's one of the directors on the East Coast for ARRL. She said she wouldn't want to be caught by the park ranger pounding a ground rod into the ground without a permit. It would probably ruin it for a lot of future parks on the air folks when they show up and ask permission if they can set up a station.
Yeah. Okay, Al, thoughts on grounding, especially portable operations?
Yeah, for my portable operation, I pretty much just use the vehicle. I've never stuck anything out, beyond the vehicle, and I've always had a pretty doggone good contact stuff. I use a ATAS 120 screwdriver antenna for my HF mobile, and never really had a problem. I've talked to South America with the thing and always been happy with it.
Okay. Another question. That's good. Thanks, Robert.
Yeah, I have a question. This is Ben, K0BEJ. I have a question for Al specifically with those that copper pipe antenna. Is it problematic to paint one or coat it with something so that it maybe is a little bit more aesthetically pleasing for those of us who live with like 20 houses within eyesight of us?
I've never painted one. I think that would be. I really don't know. I haven't thought about that. Aesthetically, the doggone thing is. You can hide it pretty well because it's only 2.5 feet tall, and even Mike, I can't remember his name, or his call sign, lives out by Black Forest. He uses one up in his attic, and it works great for all his contacts around the area, to all the repeaters and things. So I haven't tried that. It'd be something you can try, and if it doesn't work, you just dip it in a bunch of turpentine and take the paint off.
I think I've seen people
I know
paint antennas like that, and you think about it, it's really thin. A coat of paint is really, really thin, so I think it's not going to have much effect.
The recommendation or the advice I've gotten from the diamond antenna folks is you can paint the antennas, just do not use a metallic paint.
Yeah.
Nothing metal flake in there.
Good point.
Well,
Steve,
I wonder if that has anything to do. There's you can nickel plate copper plumbing parts like that, and that's probably just another electrical coating that would probably blend right in.
Yeah, if you like
it'd be kind of shiny.
Nickel look. Okay, other questions?
Bob, can you copy me?
Yeah, go ahead, Jim.
There's been some discussion on our Google groups and in EHAM about these end-fed antennas strung up through trees and lighting the trees on fire, etc. Now, us in the forest here, I use the trees all the time. Take an end-fed antenna and I have it as a inverted V thing up over the one of the limbs of the trees and never had any problem. I'm wondering if this is just somebody's pipe dream, or have people really burnt down the trees with these end-fed antennas and the current along the antenna?
If you're going to run 1,500 watts through a bare wire in a tree, you probably deserve to set it on fire. But no, seriously, for reasonable power levels, I can't imagine coupling enough power into a tree to actually ignite it. Now, on the other hand, if the tree is reasonably conductive and you have bare copper wire, you can certainly make sparks off of a couple 100 watts. And in Black Forest right now, that'll start a fire.
We don't want to do that. Most of these end-fed antennas, store-bought antennas, are insulated wire and not the bare copper wire. And whether I was lucky or not, when we put Barbara's end-fed antenna up, I put 900 watts to it, and the forest is still here. So,
Well, generally, you're going to have a string, a rope, or something coming to the end of the antenna. So the thing that's going to the tree is not the actual wire. It's a string or something like that. And if you don't have the wire in direct contact with the tree, I don't really think there's any way you're going to set anything on fire.
I think, isn't it the end of an end-fed that you're going to have to be concerned with? And if you take the reasonable precautions with an egg insulator and some string out there to tie it off, I think you'll be fine.
I would think so.
Yeah.
Well, so I'm thinking an end-fed's no different than a dipole, right? The voltage maximum is going to be on the end in both cases. Does that sound right?
Yeah, it should be.
And then like Chip was saying, when I put wire antennas up in the trees, the end that's attached, and sometimes it's like a dipole between two trees. Sometimes it's like an end fed, maybe kind of sloping upward, and I'm only attaching to one tree. I almost always have a rope coming down off the tree with an insulator, and so I'm gonna I'm going to tend to have the wire away from the tree. I know there are some installations where you kind of throw it up there and the wire's draped over the trees, which probably isn't quite as good. But if you had insulated wire, that would certainly help. And I think the big thing is 100 watts versus a kilowatt. I've never seen any behavior like this at 100 watts, but I'd be more careful at a kilowatt. You can get some serious voltage out there.
Okay, well, so far I haven't set the forest on fire, but we take the precautions with the insulators on the end of the wires. And, the dipoles, the center of the dipole is up in a tree, and then we go off to other trees, but use insulators and string. We're not going directly to a tree with the end of the antenna.
Yeah.
And I think maybe that's where all of this stuff happened. That I think there was one comment on our Google group about it, and then referencing to an EHAM thing where a guy destroyed his wife's prized tree or something. But I don't think he took the proper precautions. So there we go.
Yeah, Jim, just keep being cautious. I'm in the forest with you.
Yeah.
I'm scared to death, Scott. I'm scared to death. It's too dry out here.
So I don't run a lot of power on HF, but I've used stations that have, kilowatt amplifiers and such. And my impression is, if you're just running 100 watts, life's pretty good and normal precautions are just fine. If you start running a kilowatt, you should pay attention to the type of coax, type of connectors. I mean, you just fundamentally run them a lot more power. Does that align with your experience?
Referring to me?
Yeah,
Bob?
Jim or Chip, any of you guys that have run high power like that.
I actually run 9913 out to my antenna, so I have overkill on it. And
so you're not going to run RG58, for example.
No, I mean, granted, you're not going to have any minimal attenuation with HF, but still, I think a little bit of money spent when a little bit better grade coax, especially, I'm going 170 some odd feet out there with 9913, and it's not Chinese. It's not Chinese connectors that I'm using. It's good Amphenol kind of connectors, and take the precautions. I use the limb as sort of an arm for the antenna to get the center point away from the tree. Egg insulators, not the plastic ones, but the real ceramic egg insulators, and decent antenna rope. I think if you take those kind of precautions, you're going to be okay.
Okay. Steve or Al, you want to get in on the, what was the question? The question was about burning down trees with high voltage on wire antennas having high voltage on them.
Yeah, I would think just, keep the end away from touching the tree. Use a rope or whatever on the end to stretch it out to the tree, but not running it through the tree.
Okay, next question.
This is Lauren. I've got a question. Steve showed those links that were non-resonant, and I think it's kind of counterintuitive that we hear about, we want an antenna that's resonant on the frequency we use. And it also relates, I think, to something I've been looking into putting up, because if I'm going to string some wire, I want something multi-band. And I've been looking at the off-center fed dipole, and I think the same principles apply to that type of antenna, where you choose a length that is not resonant. And can anyone address what happens if you try to use a wire antenna, multi-band, that does have a length that falls resonant in a band, and why are we trying to do non-resonant lengths?
Yeah, Steve, you want to make a run at that? And I've got some thoughts on it too.
Okay, well, bear in mind, anything I say is based on my experience, and my experience is not based on my training. I'm a graphic designer, basically an artist. So all my experience with ham radios come from building stuff and breaking it. And then if it didn't work, why didn't it work? And maybe I'll learn something and build the next one, and maybe it'll work. But my understanding was that these lengths, 29, 35 and a half, 41, 58 on up, somebody sat down with a calculator and figured out, or a computer and figured out where these lengths of wire land relative to half-wave resonance in the ham bands. And they kind of all fall outside of the ham bands. The advantage of that is, as I mentioned earlier, the half-wave antenna, when fed at the end, you're looking at the highest impedance. And using a 9-to-1 balun, you want to try and get somewhere where the impedance is lower, like maybe 1,000 ohms as opposed to 5,000 ohms. And so that was the intent of choosing one of these lengths, and then using a 9-to-1 balun to drop it further, and then using your built-in antenna tuner in your radio to bring it down from, say, 200 or 300 ohms down to 50 ohms, so that you can get on the air and talk to your friend in New York or wherever and have a good signal. So that's my 2 cents, Bob. You might amplify on that, or if it makes sense.
Yeah, because I think it's a really good question. What's really going on there? The way I think of it is, if you, like, I put up sort of various wire antennas. Like at one point I had a single band dipole up, and at one point I had a trap dipole. I've had one of the G5 RVs, and invariably I'd have it up in the air, and I'd be doing something on HF, and I'd go, oh, well, I know this is really good on 20 meters, but maybe with the tuner I could go ahead and make some contacts on other bands. So I'd go try 15 meters and 10 meters and 40 or whatever. And sometimes it would tune up pretty well. And I was just kind of getting lucky, really, just between the way the antenna was formed and the length of the transmission line and all that. It worked out that the radio saw an impedance it could handle with its antenna tuner. But then I hit other bands where the impedance is so high, the antenna tuner couldn't handle it. And I think what these end-fed antennas do is they have the balun there to provide a certain amount of impedance transformation, so you're not just hooking into the end of the wire. But then they try and choose the wire length so that it doesn't present impedances that are really, really hard to match. And through a little bit of analysis and I think some experimentation, they kind of come up with links that tend to work. And it turns out they're not a half wave on any of the bands you care about. They're always off a bit, but between the balun action transforming the impedance down and the tuner inside your radio, you can cover a lot of bands with a simple antenna. So that's how I think about it.
Because I've seen some of the charts that show the matching at the various bands, and it's kind of crazy to look at that offset dipole, and you see these dips. I mean, they just kind of line right up with the with the bands, and it's kind of magical.
Yeah. Chip,
Can I
any
comment?
thoughts?
Yeah, remember that there's two different issues going on here. One is an impedance that makes your transmitter happy, and the other is how good a transducer is the antenna in converting electrical energy in the antenna into EM waves in the atmosphere. And those two things are not really very related. As far as that transduction efficiency is concerned, a resonant antenna does a better job of, and I've looked at it with a field strength meter. The bottom line is that a resonant antenna does a better job of transducing energy into the atmosphere. Even if you're using a tuner on a less resonant antenna and getting a good match with your transmitter, the antenna just doesn't put as much energy out into the atmosphere as a resonant antenna does. Now, having said that, I don't spend a lot of time tuning antennas. I put the tuner on and live with it. but especially if you're doing QRP stuff, the hardcore guys will tell you if they can get an antenna that's truly resonant at a particular frequency, they're going to make contacts they don't make with a tuned antenna. Okay, for what it's worth.
Steve, does that match your experience? I know you've used both going out running SOTA activations.
Yeah, a dipole is if you can manage to get one up and heating it with RG 174, which is this tiny thin piece of coax, which is not very efficient. I mean, and you don't have to get it up, 30 or 40 feet. You can be 10 feet off the summit rock because there's no telling where RF ground is. RF, the rocks might be an insulator unless you're sitting on snow. But I went out one day with Caleb, W4XEN, and he had a resonant dipole that was linked. And man, he was just getting all kinds of great signal reports. And I had a, can't remember if it was a tuned in-fed wire through a balun to the KX2 antennas tuner, and same station. I was getting reports that were maybe an S unit less than what Caleb was getting, and it surprised me. But there again, it was, we weren't operating at the same time, and so propagation could have been a factor. And signal reports, a lot of people will just give you, oh, you're 599 or you're 559, just because it's convenient and it's easy to duplicate the number as opposed to giving an accurate signal report of you're 379 or whatever.
Yeah. Hey Barry, were you trying to get in there?
Yeah, can you hear me?
Yeah. Go ahead.
Yeah, I've been playing with the 9-to-1 quite a bit here lately, and it's my understanding that the coax length, the coax is part of your 9-to-1. So I'm running a 35.5 foot antenna 9-to-1 with 75 foot of coax, and I have a 1-to-1 filter on the other end. But changing that length of coax makes a big difference in the SWR of that antenna. Any comments on that? Well,
certainly coax can act as a transformer, right? You can get different impedances out the other end. But the other issue that I was going to ask Steve about was this little thing over here. You sort of skipped over the counterpoise discussion, which some people say when you do these end-feds, you got to have a counterpoise. Many people don't bother with it. And then the other explanation I hear is that actually your coax is going to generally act like a counterpoise, which is which can affect the performance of the antenna.
Yeah, and there's some folks that don't even have, they do this little transformer and they don't even have a piece of coax. That transformer is right into the end of their little BNC connector, and that plugs into the radio. But my friend in New Mexico, KT5X, discovered that he was in effect the counterpoise. That his headphones and his paddle and everything that was connected to the radio in that case became the counterpoise. And matter of fact, he somehow got the thing detuned and wound up blowing up the final transistors in the radio because the SWR went through the roof for some reason.
Most of these antenna manufacturers with the in-fed antennas store-bought will tell you that if you have less than a certain length coax that you must use the counterpoise. And over, I think it's 25 feet or whatever it is, then the counterpoise, you forget it. I have one of those my antenna end-feds, 130 whatever feet it is, and a resonant 40-meter dipole. And going back to, the difference, the efficiency or whatever you want to call it, I did many tests out about 500 miles with my 40-meter group in the morning. And I would switch as fast as I could between the two antennas to eliminate propagation and all that kind of stuff. And every time I did it, the end-fed was 1 S unit less than the resonant dipole. So what's that, 6 dB, Bob? 1 S unit?
Yeah, supposedly.
Yeah. So that's what I got, because I had the thing all set up, and before I put it on Barbara's antenna, I wanted to see, okay, is this thing even going to be worth doing? And, over and over and over again, I was getting a 1 S unit difference between the resonant antenna and the 130 some odd foot, 49-to-1 in-fit.
I've heard a lot of the same things that everybody's saying that really underscores what Chip said, I think, and that is that a resonant dipole is a much more efficient radiator. The issue with the dipole is, of course, you're center fed, and so you need to support the center. You're going to have a big sag. So if you're going to do portable operations, it's not as ideal. The other problem is, of course, it's tuned to a single frequency or an even harmonic of that frequency. And so if you want to get other frequencies, you need to either do a linked dipole or a fan dipole or a little more complicated antenna. When you use these in-fed half waves, they aren't quite as efficient of a radiator because you're running through that transformer. Right. And that causes, I think, a little bit of an insertion loss for the layman. And I think that they are resonant on the even harmonics of the length that they're cut for. And if you move then to an in-fed random wire or long wire, those with a tuner can be tuned to just about anything, but you need a tuner. So these people that are buying all these that new ICOM 705, it doesn't have an internal tuner. So you need an external tuner if you want to use that. So I think the QRPers that I'm talking to are all saying if they have their choice and they can set up correctly and get the supports, they want to run with a tuned dipole, presumably linked dipole, so they can clip in links and change frequencies. And if they're just interested in getting up and getting out and being done, they tend to run with an in-fed half wave or an in-fed long wire so that they can tune the bands that they want to work. But you need the tuner if you're going to use the long wire.
Yep. Good summary.
So it sounds like then another way to think about it is that when you're not when you're not resonant, you're just sacrificing emitted power because you just want to communicate.
You sacrifice a little bit. Now, the one antenna that we didn't talk about that's really in the dipole arena is something, I think they call it a doublet. Bob probably knows more about it than I ever will. But the idea is that instead of feeding with coax, you feed it with ladder line. And the benefit, as I understand it, is that you still need to match so that you make your rig happy on transmission, so it doesn't fold back the power. But because there are less losses in the feed line by using ladder line, it's a much more efficient radiator. So a doublet requires an external matching unit typically. So you run the doublet wires down, ladder line down to the tuner, and then you run the coax to the shack. But I've heard that that's a pretty efficient antenna, and a lot of purists really like that. Is that what they call a doublet, Bob?
Yeah, it's basically a ladder line fed dipole. So to me, it's still a dipole, just have a different transmission line, but they call it a doublet. It's kind of, as this one's drawn right here, it kind of fits that, right? It's sort of two wires coming down.
But you would tend to see a balun where you go from coax to the twin link.
Ladder line, yeah.
Well, a lot of times you'll have an antenna tuner here that can actually handle the ladder line directly. It's got two banana posts. That's another configuration.
And then it'll match to the coax that's connected on the other end.
Yeah. Okay, well, thanks, Chip, Steve, and Al for helping out.
Yes, thank you, and Bob, too. It was very informative, and hopefully we can put this up on the website in a few days, and it might be a good resource for everyone.